In this video, we're going to do the extra practice number 1. It says, given line segment AB and line segment CD bisect each other at point M, and line segment BM is congruent to line segment CM, we need to prove that AB is equal to AM plus DM. So what's going to be really helpful is going in, and I like to use highlighters to try to help me visualize all my different line segments and my lengths. And so first, we have to fill in the blanks for the reasons in the statements in order to get to what we're trying to prove. So we know first that line segment BM, so I'm going to go ahead and I'll make this orange and I'll put it on my picture. BM is congruent to line segment CM. I'll make CM yellow. And the reason we know that is because it's given to us. Once we know things for sure and they give information to us, we can put that in the picture. So to show they're congruent, I'm going to go and put one tick mark on each of these line segments to show that they're congruent. So now I notice I'm going to have to come up with a reason for this next statement. So let's see what this next statement says. It says line segment CM, I'm going to use my yellow again. Line segment CM is congruent to line segment DM. So DM, that's right here. How do we know that? How do we know that my yellow segment and my blue segment are congruent? And so we have to go back. Let's look at what we were given. We were given that line segment AB and line segment CD bisect each other. They cut each other in half. So what this means is M is a midpoint. M is a midpoint for my yellow and blue segments. And so if I look at my proof packet, when we're looking at midpoints, my midpoint theorem is the one that tells me that the two pieces are congruent. And so we can say that CM is congruent to DM by the midpoint theorem. You could have also put definition of midpoint here as well. All right, so now we're gonna go to statement 3. And again, I'm gonna use my colors because sometimes when I highlight and use colors, it helps me kind of visualize and figure out what properties I might be using. So from here, and from my picture, I can tell based on what I have labeled that BM and DM, they have to be congruent. They both have one tick mark, but I have to think about what property tells me that. And so I'm looking at my two statements up above, and I can kind of see that because BM is congruent to CM, and CM is also congruent to DM, that means BM and DM have to be congruent to each other. And so if we're looking at our proof packet, that's the transitive property, right? It says if A equals B and B equals C, then A must be equal to C. And so the reason for statement 3 is the transitive property. We use that a lot when we're using statements up above to conclude a third statement. Some people also would think of this as like the substitution property. That would also be okay, because you can kind of think as like we're substituting line segment BM in for CM to get our third statement here. So both of those would be acceptable, transitive property or substitution. All right, and so now I'm going from step 3 to step 4. All we're saying is if these line segments are congruent, then it must mean they're their lengths are congruent. So these are essentially saying the same thing. This is just saying the line segments are congruent, and this is saying the lengths are equal. And that's just from the definition of what it means to be congruent. So I'm just going to put definition of congruence. We're just going from using our congruent symbol to using an equal symbol, but they essentially mean the same thing, right? So I'm going to keep these orange and blue. So now, statement number 5, I'm going to have to come up with that, okay? I know that the reason for statement 5 is the segment addition postulate. So I know I'm going to have some kind of part plus part equals a whole. So before I try to figure out what to put here, I'm going to look down here at statement 6. And I'm going to keep using my colors. So let's see. I've got to get DM in this statement here, my blue. Let's see. AM, I don't have a color for AM. I'm just going to put that here. And AB. So what I can see in statement 6 is, notice line segment AB is a whole. So I'm probably going to need to use line segment AB in my segment addition postulate. Remember, because I'm going to try to go from step 5 to step 6. And so line segment AB is a whole. And so I'm going to use my segment addition postulate to look at what two parts make up this whole. And so remember, with segment addition postulate, a part plus a part equals a whole. That's at our... So I know my whole is line segment AB, or AB. And I have to look at what are the two pieces that make up AB. And I see M is in the middle here. So one piece is AM, and the other piece is MB. Or we've been using BM instead of MB, so I'm going to put B first, just so I don't confuse myself. Okay, I'm going to put that in orange. So we use the segment addition postulate to state that these two parts add up to equal the whole. And I knew I was going to use this as my whole because I kind of looked ahead to notice, I have to get AB in my proof somehow. So now we got to look what's happening from these statements to my final statement. So I like to look at what's different. From 5 to 6, AB is the same. My equal sign's the same. AM is the same. What's different is BM and DM. So I got to ask myself, how did we substitute BM or DM for BM? Could we do that? And if you look up above, we notice that BM and DM are equal. So what we did is we substituted DM in for BM to get my final statement. So we substituted DM in for BM, and we can do that because they're equal to get my final statement. So to go from statement 5 to 6, we used substitution. And now we've proven that AB is equal to AM plus DM.